Lakshmi, an assistant professor in the Department of Mathematics, SNS College of Technology. This is the lecture video series on the course Differential Equations and Transforms, and now we are on to the topic of Gauss Divergence Theorem under vector calculus. In the previous videos we have got the discussion of Gauss Divergence Theorem statement and the verification process of a problem regarding the Gauss Divergence Theorem. In the last video we have seen completing the RHS of the verification process and how we will split the surfaces of the Gauss Divergence Theorem in the LHS part. Now we are going to compute the LHS part here. First of all, we have 6 surfaces as discussed here. The front face, back face, right face, left face, upside face and the downward face on the given cube. So these many integrations are to be found to find the value of this single LHS value. So first surface is nothing but S1. S1 is the first surface which is corresponding to the front face. In front face, what is it actually? It is nothing but it is crossing the x axis at x is equal to 1. Therefore, we will take the line x is equal to 1 for the first surface. And what is the unit normal vector for n cap? As usually we have discussed, the unit normal vector to n cap is I vector, to x vector is I vector. And what is ds? The surface which is not containing x is dy and dz. This is what we are going to integrate because we have fixed the x here. Since we have fixed x here, we are going to integrate with respect to y and with respect to z. Now what is there on the RHS? We have to find f vector dot n cap. So this is what we are going to find. This is f vector dot n cap. What is f vector in the given question? And n cap is dot producting with the I vector alone. So that you will have 4xz. Since x is equal to 1, we substitute it here so that it will have 4z alone as a value of f vector dot n cap. Now what is I1? The first integral corresponding to the surface S1, which is f vector dot n cap ds. What is the value of f vector dot n cap here? It is 4z with respect to the integrations dy and dz. First with respect to y you have to integrate, and secondly with respect to z you have to integrate. On integrating and simplifying, applying the lower limit and the upper limit for both of the y and z, you will have the value of I1 to be 2. So the main process here is you have to find what is f dot n. So for this we are in need of this fixation of x, n cap and the ds values. In a similar way we are going to proceed with all sort of I1 to I2 to I6. What is S2? Next is your surface 2. Surface 2 is nothing but the backward face, so that x is equal to 0 as discussed, and n cap is equal to minus of I vector and ds is dy and to dz. So what is f vector dot n cap? You are going to dot product f vector with minus I alone, so that you will have minus 4xz. Since x is equal to 0, this value is 0, therefore the whole integral becomes 0. So your I2 is equal to 0 corresponding to the surface S2. Next is S3. What is S3? The surface on the right side of the cube. So this is cutting the y-axis here, therefore we will fix y is equal to 1 here, and n cap is equal to j vector, and ds is equal to dx and dz because we have fixed the y and therefore y is not there in ds. And what is f vector dot n cap? Which is equal to minus y square, on dot producting it with the help of f vector here, which is equal to minus 1. So what is I3? I3 is equal to double integral over 0 to 1. The value here is f vector dot n cap value is minus 1 into dx dz. On simplifying it, you will have the value as I3 is equal to minus 1. So this is how we proceed with the values of I1, I2 and I3. Now we will move on to the surface S4. What is S4? S4 is the left side surface of the cube. It is actually the left side surface of the cube. There which is y is equal to 0 and n cap is equal to minus j and ds is equal to dx dz. ds is equal to dx dz because we have fixed y is equal to 0. What is f vector dot n cap? It is equal to just the dot producting with respect to minus j alone. So on dot producting it you have y square alone. Since y is equal to 0, this becomes 0. So the whole integral becomes 0 here. As usually we have done and found it to be 0. The I4 is 0. Next is the surface S5, which means the upper surface of the cube. There it actually cuts the z axis here. Therefore we fix z is equal to 1. Therefore we fix z is equal to 1 and n cap is equal to k vector and ds is equal to dx dy because we have fixed z here and therefore there is no integral for z here. What is F vector dot n cap? We are just dot producting this F vector with n cap is k vector, therefore y is z which is equal to y. Now what is I phi? I phi is equal to integral 0 to 1, integral 0 to 1 since the values for x and y are 0 to 1 only. This y have been replaced here. On simplifying it, you have 1 by 2 as a value of I phi. Similarly, for S6, which is the downward face of the cube, where it cuts the z is equal to 0, n cap is minus k vector, ds is dx and dy, and because we have fixed here z is equal to 0. So f vector dot n cap is equal to minus of yz, since you have a minus on the unit vector here. So this actually becomes 0 since z is equal to 0. Therefore the whole integral becomes 0. Now what we have done, we have found all the required integrals on the LHS side of the Gauss Divergence Theorem. See, already we have done on the double integral, we have 6 surfaces. For all the 6 surfaces, we have found the values of the integral here. Now what we have to do, we have to just add it up together as the total LHS. So what is LHS actually? It is double integral S1 plus S2 plus S3 plus S4 plus S5 plus S6. So what are these? These are nothing but I1 plus I2 plus I3 plus I4 plus I5 plus I6. What is I1? I1 is 2. What is I2? I2 is 0. 2 plus 0. What is I3? It is minus 1. So minus 1 we have replaced it. What is I4? It is 0. What is I5? It is 1 by 2. And what is I6? It is also 0. So we have replaced all the given values of the integrals and simplified it to have the LHS as 3 by 2. And previously, in the previous videos, we have found that RHS is also equal to 3 by 2. Now LHS is equal to RHS, and hence we have verified the Gauss Divergence Theorem. So this is how we do a problem on Gauss Divergence Theorem. Thank you.